with me. So class, welcome to lecture number 4th of the course, Basic Electrical Engineering. So in the last class, I told you what is element. So I told you each and every component of an electrical circuit or interconnection, it is called an element. So now in this class, I will explain some basic terminologies that are commonly used in basic electrical circuits. So these terminologies are node, branch, and loop. Okay, so for explaining node, branch, and loop, I have considered a circuit here, electrical circuit. So if you can see in this circuit, I have a 10 volt voltage source, 5 ohm resistor, 2 ohm resistor, 3 ohm resistor, and a 2 ampere current. Okay, this circuit I am considering. So in previous class I told you that each and this so if you can see this circuit, this is an electrical circuit or an interconnection. So I told you each and every component of the interconnection is called an element. So here you have what components you have 3 resistors and 2 sources. One is voltage source and one is current source, and you have 3 resistors. So there are 5 elements in this electrical connection. So what is the branch? So each and every element of this circuit, electrical circuit or network or interconnection, is called a branch. Okay, thus I can say that means any 2 terminal element in a circuit, it represents a branch. So what are the 2 terminal elements? So if you see, we'll see this 5 ohm resistor. This is one terminal, second terminal. For this 2 ohm resistor, one terminal, second terminal. For 3 ohm, this is the first terminal, this is second. For a current source, this is first terminal, this is second terminal. Same as same in the voltage, so first terminal and second terminal. So all the equipments or components, elements in this diagram, each element is a 2 terminal element. Okay. So what I am saying a branch, any 2 terminal element or component in a network or circuit, it represents a branch. Okay, so whether it is resistor, capacitor, inductor, voltage source, or current source. So how many branches are there in this circuit? Obviously, how many elements there are in the circuit? There are 5 elements in the circuit. So the number of branches in this circuit, it will be equal to 5. Okay, first branch, this is second branch, this is third branch, fourth branch, and fifth branch. So I have 5 branches in a circuit. So next definition is, what is node? So I can say, if you will see this element, that is 5 volt, this branch consisting of a 5 volt source, and this branch, 10 volt source, and this branch consisting of a 5 ohm resistor. Both these branches, they are connected at this point. Okay, so this point will represent a node. Okay, so what is a node? A node is a point where I'm taking 2 here, but it can be more than 2, where 2 or more elements are connected. For example, if I will say this point, how many elements are connected here? This element, 5 ohm resistor, 2 ohm resistor, 3 ohm resistor, and 2 ampere current, this 2 ampere current source. They all are connected at this point. Okay, so this is another node in the circuit. So that is why I am saying a point where 2 or more than 2 branches or elements are connected is called a node. Okay, how node is represented in a circuit diagram? A node is represented by a dot. So by a dot, dot, like this. So this is how we represent a node in a circuit. Okay, so how many nodes are there in a circuit, in this circuit? I will say 3. How I will say 3? I will redraw this circuit. So please look carefully. I am redrawing the circuit here. This is a circuit. This is a 10 volt source. This is a resistor. I have one resistor here, one resistor here, and I have a current source here. This is plus minus 10 volt, this is 5 ohm, this is 2 ohm, 3 ohm, and this is 2 ampere current source. Okay, so please remember that these connecting wires, these are the connecting wires, like this. Now this is a wire, these are connecting wires. Wires are not considered as element. Okay, though these wires, they have some resistance, but for practical or for solve while analyzing the network, we say that ideally the resistance of this connecting wire is 0. So this is just an connection. Okay, so this is the same circuit as this circuit. Okay, so I am saying how many nodes are there. Okay, for explaining the node, I will say you can see this element and this element, they are connected by a wire. This and this element, they are connected by a wire at this point. So I can say if I am saying that this and this are connected here, if you will consider this one node, this is connected there, so this I will say another node, hai na? So but in reality they both are the same node. Why? Because they are simply connected by a wire which represents short circuit. Okay, so if you will see the potential at this point and the potential at this point, it is same. Okay, so if the potential of these 2 points is same, that means these 2 nodes will represent a single node. So this will represent a single node. Okay, because potential at this point, and at this point is same, so it will represent a single node. So I am representing this node by B. So look at this point. Here we have a 5 ohm resistor and a 10 volt voltage. So they both are connected at this point. So this will be another node. So I am representing this point as A. Now look here, this point, this point, this point, and this point. Potential of all these points is same. Means they are at the same potential. So I will represent it by a third node C. So basically what I am trying to say here, I am trying to say that if 2 nodes are connected by wire, what do you mean by a wire? Wire means short circuit. Then both the nodes will be at the same potential, and therefore they will constitute a single node, or they can be represented by a single node. So if I will redraw this circuit, I have shown here that it has 3 nodes A, B, and C. If I will redraw its circuit like this, then it will be clear, because here you will see, okay, we have node here, we have node here, we have node here, we have node here. So how I will represent it by 3 nodes, I will show you in next diagram. Suppose I am saying this is a voltage source plus minus 10 volt. Okay, let me go like this. So I'm saying this is A. Okay, this is point A now. Positive is with A, negative is with this point. Positive is with A, negative is with this. I'm saying it is this. Okay, so then I have a 5 ohm resistor. Okay, this is 5 ohm. I'm saying this is point B. So I will draw it like this. This is a 2 ohm resistor. Let me rewrite it here. 2 ohm. Then I have another resistor here. What is the resistance of this resistor? It is 3 ohm. So 3 ohm. Then I have a current source here. What is the direction of arrow this? So I'm saying this is C, this is A, and this is B. So they both are the same circuit. They are the same diagrams. Okay, so here you can see that how many branches are connected at node B. 1, 2, 3, and 4 branches are connected at node B. How many branches are connected at node A? 1, 2. And how many are connected at node C? 1, 2, 3, 4. Look here, how many are connected at node C? 1, 2, 3, 4. 4 branches. And how many branches are connected at node B? 1, 2, 3, 4. Here I have 1, 2, 3, 4. So means they both are the same circuit. Same. They both are same. So how many nodes are there in a circuit? there are 3 nodes in this circuit. And a node, I'm saying if 2 nodes are connected by simple connecting wires, and there is no resistance or no element in between these 2 nodes, then these 2 nodes can be connected by a simple node. However, if there is any element between these 2 nodes, then they cannot be represented by a single node. Okay. Now the third is loop. What is the loop? Loop. Any closed path in a circuit is a loop. For example, this is a closed path. This is a loop. This is a closed path. This is a loop. Okay. This is also a loop. Okay. These are the loops in a circuit. So any closed path in a circuit is a loop. Okay. So for example, suppose we are starting from this point. Okay. And we are going to point B. Then we are going to point C. Via 2 ohm resistor, we are going to point C. And then again we are coming back to point A. So it is one loop. Okay. Means we are starting from the starting node and we pass through the set of nodes without passing the same node twice. Because if we will go from A to B, then we will go from B to C via 2 ohm resistor. Then again we will go from C to B. Then it is not a loop. Okay. Loop means closed path. Here you can see this is a closed path. Okay. This is also a closed path. This is a closed path. So any closed path in a circuit is called a loop. Where we start, we will start from a starting node and we will pass through a set of nodes without passing through any node twice. Means we cannot pass through the same node twice. So in this case, what are the number? You can say what is the loop? A, B, C, A is a loop via 2 ohm resistor. It is a loop. A, B, C, A is also a loop but via 3 ohm resistor. Then A, B, C, A is again a loop but via 2 ampere current source. Okay, what are the other loops in the system? For example, B, C, B, B to C, then again B through a 2 ampere and 3 ohm resistor. Then B, C, B to C, then again B via 2 ampere current source and 2 ohm resistor. So these are all the loops in a system. So I told you a loop is nothing but a closed path in a circuit. So when do we say that the elements are connected in series? We will say that the elements are connected in series if they share a single node. Series means elements are connected in series if they exclusively share a single node. They exclusively share a single node and carry the same current. So I will say, for example, I have 2 resistors like this. So I am saying plus minus, it is 10 volt. I have one resistor here and I have another resistor here. Okay. So this is suppose 5 ohm. This is 5 ohm. So if you will see that these 2 elements, okay, these 2 elements, they share a single node. This is a node here. They share a single node. Okay, and they carry the same current. Suppose current I is flowing in this 5 ohm resistor, same current is flowing in this resistor. Okay, so if they will carry, if the elements share the same node and carry the same current, then they are said to be connected in series. So this connection is also called as chain connected circuit. Connected circuit, or I can also say that these 2 elements are connected sequentially. Okay, so elements are said to be connected in series if they exclusively share a single node and carry the same current. Okay, then they are said to be connected in series. Okay, so when are elements said to be connected in parallel? So elements, for example, I am saying this is a voltage source plus minus 10 volt. Same I will take here. Case, this is 5 ohm, this is also 5 ohm. So I will say that the elements are connected in parallel. If you will see these two elements, they are connected. If I will redraw this circuit here, it will be like this. This is 5 ohm, 5 ohm. This is plus minus 10 volt. So this is point A, this is point B. You can see if these two elements, here all three are connected in parallel. Okay, but I will talk about these two only here. If you can see that these two elements, they are connected between the same pair of nodes. Okay, means this element and this element, they are connected between the same pair of nodes. So this means that these two elements are connected in parallel. Moreover, these voltage across these two elements, this resistor and this resistor, it is same. Okay, because I am saying a 10 volt source here, so 10 volt is the voltage across this element and 10 volt is the voltage across this element. So I am saying the voltage across these two elements, it is same, and these two elements are connected between the same pair of nodes, that is A and B. So these two elements are connected in parallel. So how will I define this? I will say that elements are said to be connected in parallel if they are connected between the same two nodes and sequentially have the same voltage across them. Connected between same two nodes or pair of nodes, same two or pair of nodes, and have same voltage across them. Then the elements are said to be connected in parallel. Okay. So what was the previous example I was taking? I was taking this example because here the elements are connected in series as well as parallel. So this was a circuit I was considering. So this was how much ampere? 2 ampere. This was 3 ohm. This was 2 ohm. This was 5 ohm. This was 10 volt. I was saying this was node B. This was node C, and this was node A. Okay. So if you will see this voltage source, 10 volt voltage source, and this 5 ohm resistors, means they are sharing the same element, same node, same single node. This node is connected to this voltage source and same node is connected to the resistor, and same current. Suppose current flowing here is I, same current is flowing through the 5 ohm resistor. So I will say 10 volt voltage source and 5 ohm resistor are in series with each other. Are in series with each other. On the other hand, 2 ohm resistor, 3 ohm resistor, and 2 ampere current source, they all are connected between the same pair of nodes, that is between node B and C, and they will have the same voltage across them. Okay, because they are connected in parallel. So I am saying they are connected in sources are connected in parallel. Okay, so these are the 2 points in this circuit. So these two are in series because they share a single node and sequentially have the same current, carry the same current. On the other hand, these 3 elements, they are connected in parallel because they are connected between the same pair of nodes and they will have the same voltage across them. And the third is, however, you can see if this 5 ohm resistor and this 2 ohm resistor, they are neither connected in series nor in parallel, because the current that is flowing in this 5 ohm resistor, same current is not flowing in this 2 ohm resistor, because here we have a current division. Okay, the current will divide here, and at the same time the voltage across this resistor, it will not be same across it will not be same as the voltage that will be appearing across the 2 ohm resistor. So I will say that 5 ohm resistor and 2 ohm resistor are neither connected in series nor in parallel. Okay, so you know what are the conditions for the components to be in elements to be in series. For the elements to be connected in series, number one condition is that they should be connected to the same single node, and same current should be flowing across them. For the elements to be connected in parallel, what are the conditions? The first condition is that they should be connected between the same two nodes, and they should have the same voltage across it. In series, one node should be common and current should be same, and in parallel, two nodes should be common and voltage should be same. Okay, so coming to next topic. So let us discuss about the most important thing. This is most important, which I am going to teach you. So next is the Kirchhoff's laws. So these Kirchhoff's law, I will say they are the most powerful tools that are used. They are the most powerful tools that are used for analyzing, or you can say solving, an electrical circuit. So as the name says, just Kirchhoff. So obviously the name of the scientist who developed these laws, his name was Gustav Robert Kirchhoff. Gustav Robert Kirchhoff, and he was a physicist. And he developed two laws. Okay, the first law was Kirchhoff's current law. This was the first law, represented by KCL, or you can say this law deals with charge or current. Then the second law was Kirchhoff's voltage law, represented by KVL. V means voltage, Kirchhoff's K, V, voltage V, law means law L, and deals with voltage. Okay, so this Kirchhoff's current law, it is applied on nodes, and the Kirchhoff's voltage law, it is applied on loops. Okay, so means whenever there is a node, we will apply KCL, and whenever there is a loop, we will apply KVL. So first of all, I am saying KCL, in short Kirchhoff's current law, in short KCL. So I am saying that this KCL, it is based on the law of conservation of charge, based on law of conservation of charge, and this law states or requires that algebraic sum of electric charges at a node, it must not change. That is, net charge at a node is 0, or there is no net charge, or there is no net charge at a node. Okay, so this means that I am saying that the KCL, it requires that the algebraic sum of the electric charge at a node, it must not change. Algebraic sum should remain same or should remain equal to 0. That is, the node stores no net charge, or I can say that the node stores no net charge, or I can say from this I can conclude that KCL states that algebraic sum of current entering a node or a closed boundary, entering a node or a closed boundary, it must be 0. What is closed boundary? I tell you later. So I am saying that the algebraic KCL states that the algebraic sum of currents entering a node. Algebraic sum means, if I am talking about the algebraic sum, it means currents entering are positive and currents leaving a node are negative. Currents entering a node are positive and currents leaving the node are negative. So if I will take the case of a circuit, for example, I'm saying this is a node. I have 5 branches here. I1 and I2 is going in this direction. I3 is going in this direction. I4 is going in this direction, and I5 is going in this direction. So I'm saying, what are the currents that are entering? Currents entering are, this is a node A. Currents entering the node A are I1, I3 and I5, while currents leaving are, what are the currents leaving? I2 and I4. So as per KCL law, as per Kirchhoff's current law, what does Kirchhoff's current law saying? That the algebraic sum of currents entering the node is equal to 0, or algebraic sum of currents entering the node is equal to 0 means the algebraic sum of all the currents at this node should be equal to 0. If current at this point is equal to 0, that means there is no charge at any point of time. This node A, it stores no charge. Okay, that is why we are saying that it is based on the law of conservation of charge. So KCL is based upon the law of conservation of charge. So I will say that as per KCL, I1 plus I3 plus I5 minus I2 minus I4, it should be equal to 0. Okay. If algebraic sum of currents at any time at this node is equal to 0, that means the net charge at any time at this node, it will be equal to 0. So that is why I am saying it is based on the law of conservation of charge, and it states that the algebraic sum of currents at any point at a node is equal to 0, or the algebraic sum of currents entering a node is equal to 0. So I can solve this as I3 plus I1 plus I3 plus I5 is equal to I2 plus I4. These three are entering currents, and these two are leaving currents. Okay, so can I write it mathematically? Can I express this equation mathematically? How can I express this equation? I can write as summation n is equal to 1 to capital N, In equal to 0. Okay, so if I will expand this, I can write n is equal to 1 to n In. It is equal to nothing but I1 plus I2 plus I3 plus up to In. Okay, and it should be equal to 0. What is n? And what is n? What was n here? Capital N. So n is 1 to n. What is capital N in this case? capital N is 5, first, second, third, fourth, 5. Okay, so what is capital N? N is nothing but the number of branches in this circuit. So I will write N is nothing but the number of branches that are connected to the node. So I'm saying that this capital N, it is the number of branches that are connected to the node. For example, at this node A, how many branches are there? 5. So I'm saying where N is the number of branches connected to the node. And what is IN? IN represents the current in the nth branch. Suppose when IN is equal to 1, so what was it? It was I1, that is the current in the first branch. When N was equal to 3, it was equal to I3. I3 means the current in the third branch. So alternatively, if you will see this expression, this equation, alternatively I can say that the KCL states that the sum of currents entering a node is equal to the sum of currents that is leaving the node. Okay, so I am saying that alternatively I can say that, or I can comment. Suppose I am naming this equation as equation X. From X I concluded, sorry, I will not write I because you will get confused with current if I write I. So I will write from X we concluded that sum of currents entering a node is equal to the sum of currents leaving the node, leaving that node. Okay, so the rest I will continue in the next video.